Hey everyone, and thank you so much for joining my Festive Tech Calendar session. As always, the Festive Tech Calendar selects a charity each year that they promote to try and gain donations from people who are maybe viewing the sessions. And this year, there's a Just Giving link for a very worthy cause, which is the Raspberry Pi Foundation. So if you are in a position to support that, please do so. But in my session today, I'm going to be covering automating application packaging and patching for Santa Claus. So last year I did a session that was automation based too, but it was using robotic process automation. And in that session, we were helping Santa filter through his naughty or nice list and streamlining procurement of some of the gifts and assigning coal to the naughty children, all automatically and checking it twice without Santa having to do any of the heavy lifting. Well, this year, with great power comes great responsibility. Yes, it's awesome to be progressive and get to automation and digitization for Santa's workshop, but that also means Santa needs to now maintain those systems and ensure they're patched for security purposes because he holds some very sensitive data in those data warehouses. So in this session today, we are going to focus on helping Santa Claus automatically package and patch his applications. And by the end of this, you'll have access to a script that you could take and use for yourself to replicate what I've shown here, or you could just take it, fork it, and modify it for your own purposes and for your own deployment tool of choice. Once again, thank you so much for joining this session, and I hope you enjoy. We're going to kick the session off with some slides around automation of application packaging and patching. I guess first we should set the agenda for the session. To give some context, I'm going to explain maybe why you should automate application packaging and patching. I'm going to talk about the problem with application auto updates, how application containers can help, and we'll also look at some solutions and obviously go through a demo of my lab solution and my automation script. So first on the why. Well, automating application packaging and patching of applications is becoming an increasingly hot topic in the enterprise. It is no wonder why there's such demand, though. With increasing frequency of application updates made by vendors, it's becoming an impossible task for EUC teams to keep on top of managing the packaging and deployment of every single iteration of every application in the enterprise. I researched some numbers that I thought are interesting to highlight the rapidly changing landscape of application patching. That includes an increase in the number of critical vulnerabilities in 2022, with the number of critical vulnerabilities up 59% according to research by The Stack. Ransomware groups collectively listed 514 victims on their data leak sites in September of this year, breaking a previous record set in July of 502, according to the NCC group. So while that first number is from 2022, because it's a year-on-year metric, and at the time of this recording, 2023 has not actually finished yet, it seems like 2023 is going to be another bumper year in terms of vulnerabilities and exploits. Rapid7 reported that 56% of vulnerabilities were exploited within 7 days of public disclosure, and the application that I personally use as a benchmark for enterprise application updates, Google Chrome, was moved to a more frequent update cadence back in 2021, going from a major update every 6 weeks to a major update every 4 weeks and minor updates every 2 to 3 weeks. But in reality, there was actually more frequent updates being completed, and now, more recently, Google moved to release minor updates every week. And even since that announcement, I've been noticing that they've staged new updates of Google Chrome on their site even more often than every week. And when you put all this data together, it paints a picture of a large increase in the number of vulnerabilities being discovered and disclosed, and over half of critical vulnerabilities have an exploit within 7 days of being disclosed. And as a result, I'd imagine we'll see vendors moving toward more frequent application updates like Google have for Chrome, and then there's an increased pressure on enterprise IT teams to quickly act to mitigate vulnerabilities in their organization as they are being disclosed. So it's just an overwhelming, impossible task for an enterprise to package every single iteration of an application update. So let's talk about it a little bit more and why enterprise might feel inclined to just simply enable auto updates within applications and let the vendors patch the application automatically as they see fit. So as a result of the seemingly impossible task of handling application patching, some organizations have relented and handed over control of application updates to the vendors. This is something enterprises would have scoffed at just a few years ago. As an application packager myself, in the past, step one when onboarding a new application was checking to see if there was an auto update feature and figuring out how to disable it. Now, some organizations will simply allow those auto updates for at least some of their applications. There's an increased pressure on organizations to do everything to protect their customers' data, and that includes avoiding knowingly using out-of-date vulnerable applications on their network. But does this change in allowing auto updates, at least for some applications, come in part because businesses now trust vendors more than they did in the past? Personally, I don't believe so. The fact is, vendors still deliver crappy packages. Application updates still fail. I believe this change in accepting application updates is reluctant acceptance. Organizations are simply more willing to accept adopting a reactive approach to an application patch gone wrong and mitigating an application update that causes problems than they are to risk falling behind on application patches, getting attacked using a vulnerability in a version of an application that they had not patched, and then having to publicly disclose that they were breached using a known vulnerability that they had not patched against, thus making them liable for leaking customer data by not being on top of the security. While allowing auto updates is a proactive measure, you should have adequate tooling to monitor application updates to ensure they actually complete. Unfortunately, if updates fail, IT is left to react to this and mitigate the issues. If you're relying on traditional solutions, that can mean slow deployments and fixes that take hours or days to complete. Imagine Santa Claus has an application issue 2 days before Christmas, but it can't be resolved before he has to go out and deliver presents. Disaster. Unacceptable. But unfortunately, that's the reality of most enterprises today. We just accept that risk and we accept that these problems can happen and they can linger for days. While this is the case, and it is kind of accepted, the juice is considered to be worth the squeeze by some because it is better than wasting hours or days fixing failed updates and broken applications than dealing with the security breach. For example, the HSE, the health system in Ireland, got breached by a ransomware attack, and the ransomware group actually gave the decryption keys, but still, over a year after getting the decryption keys, some of the services were still affected because it was a manual process to decrypt the systems and to get things back up and running. So, yes, broken applications does suck, and yes, Santa Claus being stuck 2 days before Christmas, being unable to process things, does affect Christmas Day for some, but it could be worth it compared to losing days, weeks, months, or even years due to a ransomware attack and losing your customers' critical data. An alternative to allowing vendors carte blanche access to potentially mess up your employees' machines, break applications, and ruin their workdays is using a middleman such as Chocolatey, Winget, PatchMyPC, or another platform integrated with a deployment tool like Configuration Manager or Intune. This would at least give some visibility and control of the patches after they occur, and some remit to at least push an uninstall and a reinstall of an old version if something goes wrong. This is not ideal, however, as I'm sure everyone is aware that these traditional deployment tools or even the modern provisioning tool can be cumbersome to use and slow, so backing out an application update can be a multi-step process and can be disruptive to users. Some enterprises, particularly those in finance, are unwilling to use a service like Chocolatey, at least Chocolatey's public repository, to augment their own packaging efforts. If they do use such platforms, they tend to keep their own private repository and maintain their own packages from my experience. But regardless, if you look at these third-party services and at the native auto-update features in vendors' applications, there is a glaring underlying risk. And that risk is the fact that almost every package being updated is an MSI or EXE. which Microsoft PM John Vinsel once referred to as XP lifecycle era technology. It's not designed for deploying and patching on remote endpoints, so if Santa Claus brings his laptop with him on the fateful Christmas Eve and fateful Christmas morning, and an application update gets pushed during the night, there is a chance that it will not complete, it will not reach the device may be offline, and if it does install, there could be a problem, and then getting the application rolled back will not be graceful due to the underlying package technology. These current package formats do not handle context switching well. So for example, if you deploy using system context, but an application needs to install some components in the user context, like in the user profile, this may require the use of active setup. Custom actions can basically do anything good or bad within MSIs and have been used in cyber attacks. So that's actually a risk all enterprises face by allowing the install of Windows installers. And unfortunately, vendors have never followed best practices around using MSIs. For example, they misuse the update table, they abuse custom actions to basically wrap their own installer within the installer, and they do not use any of the tables at all in some instances, negating the self-repairing features and a lot of the benefits of MSI to begin with. And sometimes they mark components as permanent when they don't need to be permanent, leaving junk behind on a machine and potentially breaking an application if you do try to roll back if the newer version leaves something behind after uninstall. Unfortunately, there's a lot that can go wrong. But with that, let's jump into a solution I run, which is designed to run without interaction on a set schedule. It takes the latest vendor installation media and packages it up as an application container, and then deploys those using containers. So this is just my own personal example, but my script is available on my public GitHub repository. You could take it, you could fork it, and you can modify and use your own deployment tool and own packaging solution of choice. You probably just have to swap out a few lines of the code, and that's about it. And for someone like Santa, who's maybe new to the digital world, this is perfect because he obviously does not have an enterprise scale team for managing his IT, so why not automate this? So a quick summary of what my solution does. I have a script that checks to see if there's a new version of an application available. If a new version is available, it auto packages that version. It then publishes this version to an early adopters ring. So that kind of ring methodology that Microsoft uses for Windows updates, I'm applying that at the application level here too, and pushing to an early adopters group. And then if something happens or there's something wrong with the application, maybe a feature was changed between versions that was important to a certain department, well, you're going to get notified by those early adopters, so it hopefully will not affect too many employees as it was a limited deployment. And the last step that my script does, it will notify the EUC team that a new version of that application was packaged and deployed to that early adopters ring, just to give visibility that there was a change, just in case calls start coming. They'll have a record and know, oh yeah, this application was actually updated last night, and that'll give them insight and a quick reference to know, oh, maybe I need to roll back this update if there's a problem. So for my particular script, if you want to use it as is, there are a few prerequisites. So I'm creating containers, which requires the Cloud Paging Studio, which is a Numescent product. You know, all visibility, I work for Numescent, and it is going to be part of my demo. I'm going to keep it very light on the Numescent and the actual product talk, because this is my own personal venture, and I do not want to be seen to be promoting one technology over another. But for this example, I am using Cloud Paging application containers and Cloud Pager for orchestrating and managing those containers automatically. I'm also using the Evergreen PowerShell module primarily, but I also have integrated Chocolatey and Winget too, if you would like to use those as sources for your packaging. Again, it's up to you. I'll explain my preference for the Evergreen PowerShell module over something like Chocolatey and Winget for this process as we go. Finally, I use a product called Automate, and this is for essentially running my automation on a schedule. So I have Automate run through every night saying, oh, check to see if Google Chrome is a new version. If so, package it up and deploy it. So that's simply basically my pipeline that's running on an automated schedule. But again, if you have something different that you want to plug in for that point, you can. But enough talking, on to the best part of the session, the demo. Okay, so here we are on a demo VM that I've got here. This is a virtual machine. It is relatively clean. I do have the Cloud Paging Studio installed, which is going to be used for generating my application containers. Again, if you don't want to do this step, if you do not want to convert into containers, that's fine. That's your prerogative. I do choose to do this because containers are cleaner, it avoids things like application conflicts, and it gives the ability to cleanly roll back application updates if needed, which is important to me with such frequent application updates required. But like I said before, I'm not going to go in too deep on that because I don't want to be product specific or biased. But what is also important to know on my VMs, if I go to PowerShell, you will see I've got other tools available here like the app installer, which is Windows Package Manager, and we can do a quick example, maybe do winget search instead, for example, just to show you that, yeah, Windows Package Manager is available on here. And I'll also do Choco search maybe instead. Yeah, I didn't test that beforehand. Choco search. Oh, it would help if I actually typed it properly, I guess. Okay, yeah. So, yeah, just to show that, yeah, I'm using PowerShell. I'm querying both Windows Package Manager and Chocolatey. Those are available here. But also, I've got Find Evergreen App, the Evergreen PowerShell module, which is awesome. And this is going to be a focal point of my demo today. But you can see here, the Evergreen PowerShell module contains a list of many, many applications. So unlike Chocolatey and unlike Windows Package Manager, this is not a hosted repository of these applications. It is actually a PowerShell module that contains data about applications, including useful data like the actual version for the latest version of the application available, and also where you can get that latest version. And I like this over something like winget because there's no man in the middle. It's using the vendor's provided installation media directly from their site. But let's take an example. If I go to perhaps Google Chrome, here you can see we've got Google Chrome Enterprise, and it looks like this is the name. So let's go a little bit deeper on this. Let's do get Evergreen app Google Chrome, and we can see it has returned a whole lot of data, including the architect type. We've got that very, very useful URI, which is a direct download link for the latest version. And it even breaks down the different versions by like the stable release, by beta, and so forth. So obviously in an enterprise environment, you always want to be deploying the latest like publicly available stable release. So that's something I'm going to use during this demonstration. But based off of all of this, I also have a script. I'm going to go to my PowerShell ICE here. I'll go to my scripts, and I'll open my main packaging script. So I won't go too deep into this right now. After the demonstration, I'll dive through at least what I feel are some of the more important parts of the code, and also parts that you can maybe swap out for your own alternative solutions if you'd like. But I have examples here, and I have what the parameters are. So for example, I've got these parameters here. Let's actually go ahead and run this script, and I'll explain what's happening as we do that. Okay, I'll just do a quick change directory since I'm going to run this manually. And I'm going to go to my folder, scripts, and I will type in, there we go, that's the script I want, and I'll pass my parameters. Okay. And I did cheat a little bit. I copied and pasted. But this is the basic building blocks in terms of parameters of what you require to use my script. So you can see I've got the app name, and this is the app name as it was shown within the Evergreen PowerShell module. So it's Google Chrome without a space. But if I wanted to use Winget, I could use like the Winget alias or the app name within Winget. So I believe that's like Google.Chrome over there. Or alternatively, if I wanted to use Chocolatey, I could use whatever is equivalent there. I can give a publisher name, source package type as MSI because the Evergreen PowerShell module, for example, might support exe or MSI. So I'll set it to MSI. The source channel, again, because the Evergreen PowerShell module gives you the option of like beta as well as the stable release, I'll go for stable. Image file path. So I've actually downloaded a Google Chrome image for the icon. I'm going to supply that as well. I'll set the command line for the main executable, which is chrome.exe. I'll set a description, and I can even set some file or folder exclusions too. So for example, I want to exclude the actual Chrome updater because I don't want Chrome, after I've delivered the package, to auto update itself. I want it to be updated by my own automation process using this script. Thanks to the awesome Paul Eden for that tip. And finally, for this particular example, I'm going to pass the parameter of Chocolatey false because I'm not using Chocolatey as a source. I'm going to set Evergreen to true because I'm using the Evergreen PowerShell module. And I'm going to set Winget to false. But I can select whatever I want. You know, Chrome is available in Winget. It is available in Chocolatey. If I prefer to use those, I can actually do that too. If I wanted to, and I won't for this particular demo, but there's also an optional parameter for WorkPod ID. And this reflects what's available in CloudPager, which I'll show very quickly here. We'll see I have these things called workpods, which are just logical groupings of applications. So for example, I have my IT workpod. It's got the IT team's applications. I've got finance. It's got like Bloomberg and Adobe Acrobat, constructions. It's got the AutoCAD applications. But I could also have a workpod that's for my early adopters group. And these applications are auto-packaged and delivered for UAT. And then I can assign maybe my group of applications. You know, I know that, say, Firefox, brand new. And I'll assign it to my early adopters group. Okay. But again, I don't want to get product specific, but essentially once I've got an early adopters workpod created, I can programmatically deliver my applications to this early adopters group. And once it's delivered up to this workpod, every user that's in that group, which in this case was my demo 3 early adopters Azure AD group or Azure Entra ID group, they will get delivered that new version of the application. In this instance, I won't run it with the workpod ID for now. I will show an example of that working in just a moment. And without putting the workpod ID in, it's not going to auto deploy it to like a user acceptance tests group. It's instead just going to publish and stage that within my CloudPager tenant so that I can deploy it later myself. But if I run this script, we will see the very first thing it's actually doing. You won't be able to see it, but I can tell you it's doing it. It is seeing what the latest version of Google Chrome Enterprise that's available within the Evergreen PowerShell module, which reflects the latest stable release available on Google Chrome or on Google's website. It sees if that version is available currently in my CloudPager tenant, and if it's not, it goes ahead and does this step, which is it auto-packages it. I am not clicking on anything. This is just completely happening by itself via the script. So there's some logic built into the non-interactive packager script, which is publicly available on the new Messing GitHub repository and is a script that my script actually downloads when you're first setting it up. And that will handle this auto-packaging of the application, and it should also gracefully finish as the application has been installed. Okay, and we see that it is now compiling this application into an application container. And perhaps at this point I'll use video editing to speed up this part so you don't have to sit through this dialogue. But essentially it's generating, the installed application for Google Chrome into a container. Of course, the beauty of being able to automate this is that you don't actually have to see this process happening, right? It will happen in the background. And at this point, it's going to go ahead and upload the completed package or application container up to my Cloud Pager tenant. This part of the process is relatively quick, but again, I'll maybe use video editing so you don't have to sit through it. And at this point, if I go back to my Cloud Pager tenant, and let's refresh, I should see the latest version of Google Chrome for December 11th has been packaged up, and it is uploaded and available within my Cloud Pager tenant. So this can be awesome for applications like, say, the remote desktop client, for Zoom, for Chrome, very commonly used enterprise applications that are publicly available but get updated a whole lot. But let's maybe take a look at the script, and then we'll get back to maybe some more demos and even discuss some features that are also available within the script that I haven't shown yet. If you go to my personal GitHub repository, you will be able to download this script for yourself. You will also see that there's a README in there, and there's an accompanying script that you can run on a clean virtual machine to essentially download all the latest automation scripts that I have and to help prepare your VM for auto packaging. You can just follow the instructions as seen here if you want to follow my exact script and using the exact tooling that I have, but you could also just take my script and modify it for whatever packaging tool or environment you require. So I figure I could go through the entire script, but it might be a little bit boring. It may take a little bit long, but I would like to highlight maybe some of the important parts of the script and talk a little bit about what I haven't shown yet. Let's very quickly go through some of the more important parts of the script. It won't be the entire script, but just enough that will get you started. So first off, some of those parameters and variables. As shown, we use the application name, and this is the application name as it's found in the Evergreen module, or possibly the alias or name in Windows Package Manager or Chocolatey. Publisher name can be set. This would be useful for use with something like Cloud Pager, or possibly it might be information you want to provide for something like Intune or whatever deployment tool you're using. Next up is a set of parameters, and these parameters define the package source. So if you want to use Chocolatey, Chocolatey would be true. If you want to use Evergreen, Evergreen would be true. And if you wanted to use Windows Package Manager, Winget would be true. Now, there is a check within the script to make sure that you do not have more than one of these set to true when running the script, because you can only have a single source in order to do the package. Next up is a set of parameters that are not mandatory, and this is because not every application supports multiple languages. So an application that does support multiple languages, and you'll find multiple languages available within the Evergreen PowerShell module, is like the Adobe Reader product. There might be English, Portuguese, what have you. Also, there's packages that may have different types, like Zoom, for example. There's the full Zoom version, there's the Zoom VDI version, and so forth. So you're able to define that with this parameter too. An image file path. This will be displayed in Cloud Pager, both in the storefront and also within the Cloud Pager UI that administrators will see. And for bonus points, I also use this image when creating the Teams notification that I'll show in the next demo. Similarly, if you're using something again like Intune, maybe something like Citrix App Layering, an image might be useful there too, because you can set the tile image to whatever you want. Arguments for this script. It's only required if the application in question is not an MSI or an MSIX. So essentially a setup.exe where a silent install parameter is required. Something that might be non-standard. Command line for me, this is the command line required for launching the application. And if you do fork this and use it for your own environment, this may still be useful to you, because if you want to do something like set up a detection method in Intune, it might be useful to base it off this. In WorkPod ID, I'll show that in use in a demo video that I'm going to throw in at the end of this. But in my example of just manually running the script, I did not set this parameter, but if you do, it will automatically publish the application to a workpod that is assigned to your users. So it's essentially helping you complete that end-to-end packaging and automated packaging flow of packaging the application when a new version is available and actually deploying that completed package. Description is pretty straightforward. It just sets a description within CloudPager. I did set this as mandatory, but it does not have to be, and I'll explain that in just a moment. But again, a description field is something that's common across most deployment tools. And finally, I have a set of package exclusion options that could be useful for doing some cleaning and standardizing if you know a particular application should have a certain exclusion set. So in the body of the script itself, a very important thing if you are using CloudPager, you will want to set your API key. This might be similar for a cloud hosted deployment tool that you may be using. You're likely going to have an API key in order to associate with your tenant. Also important, in order to detect if there's a new version of an application available, you first have to know what version of an application is published within your tenant. So in CloudPager, I'm simply looking at my tenant, seeing if the application that I'm trying to package is already there, and if so, assigning the version of what's already there to a variable. I then, for instance, using the evergreen as just an example, now the code is slightly different for winget and for Chocolatey, which unfortunately does not use as standard PowerShell output, so there is a little bit more work involved, but that's covered in my script if you'd like to see it. But for a better example or a more straightforward example, here's Evergreen that does output in a standard PowerShell output, where I assign the latest version and the latest version's URI to variables so that I can use that if a new version is available, or rather a newer version than what's available in my tenant currently. Very straightforward. I set some global variables for things like working directories in order to download the MSI or EXE from the vendor site. Also where to output my completed application container package to, and my Teams channel URI for sending the notifications. A very, very important piece of this script is simply validating to see if there's a newer version than that which has been already published within my CloudPager tenant. And should be noted that if I happen to run this script against an application that's not even published in my tenant at all, like no version is, the script will still go ahead and automatically package it because it's comparing a valid version to null, and a valid version is going to be not equal to null. So the script can be used for packaging net new applications as well as application updates to existing apps in your tenant. And if a new version or new application is detected, it's going to start this part of the script, which is the main meat and potatoes. It's going to create those global output directories. It's going to go ahead and download the latest version of that application from the vendor's website, and it's going to begin the process of automatically packaging. And for auto packaging within an application container, it's going to create a JSON file for me on the fly. This is in order to use the Numescent Cloud Paging non-interactive packager that requires a JSON file. But luckily, there's a script from that available via Numescent, so I'm simply injecting that existing script into my workflow, and I'm passing the parameters that I've already set for running this script. Something I did not show in my demo. So I did mention that a description is not mandatory. Well, in my script, I also have injected some code for actually using OpenAI's ChatGPT API. So if you don't want to set a description, say, for every application, there is some lines of code in there where you can put in your ChatGPT API or OpenAI API key, which is difficult to say, and then have AI generate a description for you. And now with the latest version, I haven't tried it yet, but with the latest version, the actual ChatGPT input allows you to request something like a graphic or an image. So you could potentially have it auto-generate and create that icon image for setting the actual application logo too. Now, while this is possible, I did select to just comment it out of my code because I don't think everyone's going to have access or be paying for that API. Also, because currently, every time you run it, it does incur a cost to use this API. So if you do automatic packaging and patching of applications for a lot of applications, it does have the potential to cost like fractions of a cent each time you run that, but that could add up if it's like thousands of applications. After the application packaging has completed, I simply grab the full path to the output of package. In this instance, it's a .stp for the application container. If you're using your own solution, maybe that would be a .appv or MSI or MSIX or something. In my script, I use the CloudPager API to then publish and upload it to my CloudPager tenant. If the workpod parameter has been passed, it will go ahead and automatically add this application with the comment for tracking purposes to my workpod of choice. And one of the final steps, it's going to send a Teams notification if I have provided a Teams channel URI. At this point, let's continue my demo. I'm going back to a virtual machine here where I have Automate installed. I want to show you this because this is how I run my script on a schedule for various different applications that I want to automatically package and keep up to date. So you can see some examples of my applications that I run the scripts on. For example, there's 7-Zip there, Adobe Acrobat Reader, and here are my test plans that align with those applications. And you can see, for example, I've got that Chrome, which is the application we ran the script manually for. And if I open up Scenario Builder, you may remember this from my Festive Tech Calendar session last year because we used this for our RPA, our robotic process automation. But this time, since I'm using a PowerShell script, I could still use Scenario Builder with Automate for running this on a schedule, but essentially all the robot is doing is running my PowerShell script with the parameters and the variables filled in on a per application basis. So this is the one for Google Chrome. You can see app name is Google Chrome, publishers Google. I'm doing source package type MSI. It's going to be the stable channel, and I've got the description and all of that good stuff. But for now, let's just see what that looks like running from Automate rather than manually running the script, just to show you that it doesn't require any interaction. I don't have to open up PowerShell and run the script. It's just going to run, and there's not going to be a whole lot of indication that it's even running. So you can see here, I've got a tester. It's going to run on my packaging machine, which is already open, and I'm going to click play. It could run on a schedule, but that's hard to show in a recorded demo. So I'm going to go over to this packaging machine, which was configured within Automate to be used. And we could see if I go to details in Task Manager, the PowerShell process is running. And if I go to my scripts folder, we could see that the output directory, those global properties that were determined in the script for the package, those are created. And that's really it. The robot is doing the work. It's running the script, and the script is running in the background, and you don't even see like a pop-up window. It's just doing its thing. And again, if I go back to CloudPager and I just refresh the page, you can see as an example that it's updated Chrome. Now this is a recorded demo. I recorded this earlier this year, and I'm just dubbing over this part. The rest of it was brand new, but I'm reusing this section just to illustrate running with Automate. So something else that I did want to show in this recording is, again, going back to that early adopters workpod idea. We could see we've got some applications already assigned in this workpod, but I would like to have the automated process automatically put an application in there. So I'm going to go ahead and delete Zoom from my applications, just because at the time of recording this, I already had the latest version published. And this time I'll show you, what the script is going to do if an application doesn't already exist in my CloudPager tenant, which, as you remember, when going through the PowerPoint slide showing the script, if it's equal to null, then it should just package the latest version no matter what. It doesn't matter if there's a newer version, because there's no newer version in my CloudPager tenant, since there's none in the CloudPager tenant at all. So at this point, if I go back to Automate And this time we can click play on the package Zoom test plan. And maybe I'll open Scenario Builder just to show you how similar this is, because really all I'm doing is reusing or copying and pasting one into the other, because the parameters are typically the same. There might be slight differences, like app name is Zoom, publisher Zoom, and the source platform for this one I believe was Meetings at the time, because there's several different versions of Zoom available. And we can see on the machine, again, it's downloaded the package and it is going ahead and packaging it into a container. Now if I skip over to my Cloud Pager tenant and refresh, voila, Zoom was packaged and published up. But this time, if we go to our work pod, we can see that it's in that work pod. So at this point, I'm going to go to a machine where I'm logged in as a user that's been assigned to the work pod. And if I open up my Cloud Paging player, which can run headerless, users don't have to see it, but for this purpose, it's useful to see it to illustrate. But we see that the applications that are assigned to the work pod have been delivered, including Zoom. But one final thing I want to show is this application here, which is a VMware application. And if I go into Scenario Builder this time, it's not the same. It's not that simple copy and paste and just rerunning the same PowerShell script, but with different variables populated. This time, there's actual actions. So it's launching a browser and it's doing several clicks and keystrokes. So again, if you didn't see last year's session by me, it might be worth checking out, because I go over robotic process automation. But this one uses robotic process automation. So if I click play, you can quickly see on the VM, this one actually seems like it's doing something. Now you might think that, well, I'm just doing these actions manually. I'm not. The robot is actually going out to the website. It's downloading this version of VMware Horizon Client, and it's going to package it into a container. The reason I even did this was because when I was originally recording this demo, the version of the VMware Horizon Client that was available in the Evergreen PowerShell module was not working. The URI was throwing a 404 error. So I was like, oh, well, this might be a good opportunity to show the RPA being used as well. So this great thing about having Automate doing the scheduling and running of the script is if there's applications that cannot be scripted programmatically, you can still achieve automation with them using the RPA. And just skipping forward a bit, we can see it's getting to the point of packaging the application, and then it's going to go through the upload as well. And it should have published it into my early adopters work pod, because the work pod ID parameter was populated. So now if I go back to my desktop, we'll just go ahead and launch those applications. We can see the VMware Horizon Client was also delivered, because it will deliver it even in an active user's desktop session. I was already logged into the desktop and it delivered it anyway. So we see that Zoom does launch, and similarly, VMware Horizon Client should launch too. And just opening up the Cloud Paging player just to show that these are indeed running the application containers. And to tie a Christmas bow on this session, let's do a quick summary of what we've covered. As covered at the beginning of today's session, application patching must be automated. There is not an IT team in the world large enough to keep on top of packaging every application update required in a modern enterprise. While the temptation to allow auto updates to occur is attractive, enabling auto updates leaves enterprises vulnerable. There is a lack of visibility and control when something goes wrong, and even just measuring patch level and compliance after a vendor announces an application vulnerability can be difficult. Application containers and container orchestration can be used to reduce the risk. A great benefit of containers realized by infrastructure teams for years is that containers can scale elastically, be deployed quickly and consistently, and roll back to a previous state in a snap, which can be great for desktop teams too, as they don't need to stress over trying to back out an application by pushing an uninstall, then pushing and install the previous version to get it back to a working state when a patch goes wrong. And sometimes when doing that step, it doesn't work because the newer version left some applications files set to permanent and left those behind even after you uninstalled it, which can cause conflicts and lead to an outage that's prolonged. With containers, everything is streamlined. Containers also provide benefits by reducing exposure of applications on the system, thus reducing the surface layer for attack by the bad guys. And as shown in my demo, fully automated, end-to-end packaging and patching is possible. The technology exists now. You don't have to wait. This is not a pie-in-the-sky dream. It can be realized for pretty much any application, because even those that cannot be handled through standard scripting could be handled using an RPA. And the end result is a happy Santa. He can continue to embrace digitization of his operations whilst keeping sensitive user data secure and his workshop humming along. Thank you so much for joining my session today. Please do consider donating to the Raspberry Pi Foundation in conjunction with today's event. And Merry Christmas and Happy New Year.